Hi everyone, we're on tutorial 2, we're looking at the second problem. I'm going to try to be quick. It's a short problem. These videos are taking too long, but I do want to explain it clearly, so if it's 20 minutes or 30 minutes, that's what it is. Right, it says write a program phone words. It takes two command line parameters. The first is a string of 7 digits, so that's just a telephone number without a prefix. Ignore any hyphens, minor, okay? And the second is the name of a dictionary file. The name of a file. The dictionary contains a list of words, 1 per line. The program must read the words and print out all 7-letter words or 3-letter words followed by 4-letter words in the dictionary that can be formed using the standard phone rules. For example, 266 spell out compute, and here is the corresponding key. 2 can be A, B or C, so C can mean 2 can mean C. 6 can be O, and then the next 6 is M. 7 can be P, and then U, T, E, and so on. Standard phone rules. Where does this come from? You guys are too young to know this, but before we had smartphones, we had what were called feature phones. So this is a typical classic Nokia 3210. Everyone had one, and they were great. I wish I still had mine. As you can see, not many keys. It's not a touchscreen. In fact, it's black and white. And if you wanted to type a text message, which is about all you could do with this phone, apart from making calls, and you wanted to type compute, you would press the 2 key 3 times quickly to get to C. Then you'd press the 6 key 3 times to get to O. Wait a sec. Then once to get the M. Then you press 7 once to get the P. You'd press 8 twice to get the U, wait, once to get the T, and 3 twice to get the E. So as you can imagine, it took a long time. You made a lot of mistakes. If you wanted to type a 2, you'd have to press the 2 key 4 times. So life was hard. But bottom line is that this is a really useful feature, which is still used today, because many phones, manual phones, even smartphones, still have this mapping. And the point is that if you have to remember a phone number like 2667883, that could be quite difficult. So if this were the number for a shop, it looks difficult to remember. But if you know the shop was called Compute, then you could just spell out Compute, and that would be the phone number. So it used to be a very useful and important part of life. Rightio. At the bottom it says, here is a link to a dictionary to use for testing purposes. And I've in fact downloaded the link. I'll show it to you in a second. So let's just recap. Phonewords.java, a string of 7 digits, no hyphens, ignored. I'm just going to assume it's just 7 digits. I'll skip over the part where we ignore hyphens. And the second is the dictionary file name. And I think I might even change that. I don't want to change these problems too much, but I want to show you a better way of doing things in some sense. Okay, right. Let's move this out of the way and write this program. So here is project Tut2. I'm going to create a new Java package called phone words. Oh, forgot to click. Phone words. And inside there, I'm going to create a new Java class called phone words. Okay, right. And it has a main, and that's about it, I think. So, it's supposed to take 2 strings. The first is the number, and the second is the dictionary. the file name for the dictionary. But I am going to hard code that because it'll make life easier if we use the same dictionary all the time. I mean, in real life, maybe you want to have a Spanish word and you've got a different dictionary, or you've got a dictionary with just funny character names, people's names, who knows what you have. But I'm going to stick to a standard dictionary, so I'm not going to use the second command line parameter. I'm going to say my dictionary is always the one that was given to us for a very special reason. And that is that if we open it up, we see that it's a list of words. They are all either 7 character, like, let's find a word that we'll all know, like absence, or they are 4 characters, like able, or they are 3 characters, like, what's a 3 character word that we know? Ace. There's one. Okay. So there are all these different words in the dictionary, and I don't know. We need to read all of this or work through them. See, the problem is that let's think about this a little. We read the number, and that number can be translated to many different words. So if I have the number, let's just say it's 234. That can be, 2 can be A, 3 can be E, D, and 4 can be G. F. But 4 can also be G, and it can be H. And 3 can be E, so that can be lots of different words for each number. So how do I know which word? Do I have to generate all the words and check that they're in the dictionary? So I take 2, this number, but if there are 7 digits, 5, 6, 7, 8, how many words can that be? Well, 2 has 3 possibilities. There are 3 letter possibilities for 3, so that's 3 times 3 times 3 times. I think, let's just get back to the Nokia phone, or even that little table. I think one of them has a lot of possibilities. 7 and 9 have 4 possibilities. So let's say this telephone number was in a 9. That's 3, 2, 3, 4, 5, 6, 7, 4 possibilities for 7, 4 possibilities for 9. And this is a big number. This is 243 times 16. That's thousands of words I'll have to generate and then check each of those words. It's going to take too long. So I'm going to use a different technique. This is like a puzzle. How do we solve this puzzle? And I think we can solve the puzzle by doing the reverse, by saying that let's take all the words in the dictionary. Let's take a word like this. Now let's just take these 3 words. The first. So we're reading the dictionary, and I read ABA. Well, I know that can only be 222. And ABC, ABAC, a back, I don't even know what that word means, can only be 2222, because all 4 of these letters occur on key 2 of my phone. A, B, and C, they're all on key 2. And this one, the first 5 are all on key 2, so that's a 2, 2, 2, 2, 2. T is on 8, and E is on 3. So, as I read the dictionary, I can translate each word to its digit equivalent, and check if, let's say, the number starts with 222. Let's just think about the sevens first. If we translate the 7-letter words, we can check if this is the phone number if this is our phone number. Okay, right. So this is what I'm going to do. So I'm going to read the dictionary, scan through it. Let's just do the 7 letters first, and check if that's the number. So how do we read a dictionary? Well, there are many ways, but one way that you've read about, but I don't think we talked in class about enough, is to use this in class, or maybe it's still coming, in which case. But this is part of the standard library, if we import it from Princeton. New in, and I give it a file name, and I said that I would fix the file name to 237.txt. That's the dictionary we were given. So, how does this work? Well, it works exactly like standard in. Standard in we used before, and we could read characters and strings and integers from the command line. In works exactly the same way, but now I can create a new instance of in and give it a file name to open, and it'll read from that file name. So this is how I can read a whole file. There are other ways of doing it, and in fact last time we used a scanner, but this time I want to use in. So I'm going to say while in.has the next line, read the word. In.read, can I read a string? Yes, I can. Okay, read string. So that'll read the string, and then I'm gonna it sends back a string. That's the word, and then I'm gonna translate the word. Translation. Let's write it out. Translate the word, and if the translation is equal to my number, I'm going to print the translation, the word. Okay. One thing that's different from an in is that at the end I want to close it. So I don't want open files hanging around. Okay, so I'm going to keep this here just for record purposes, and I'll keep all the this here. That was part of my explanation. Right. Okay, and all that's missing is translate. And let's write function translate, or method translate, static. It sends back a string, and it takes a string, which is a word. Okay, and how do I translate a word? I'm going to start with an empty string, and then I'm going to walk through the word, look at each letter. So I is going to start at 0 while it's less than the length of word I++. And now I'm going to take the letter word.char at index I. If this letter is more than or equal to A, are they all small letters, or are there some capitals here as well? What would be a capital? What 7-letter word starts with a capital A? It's a long file. Let's just quickly scan. Let's see if we can see any. Okay. I'll need to double check, but I think they're all small letters. Yes. I think all the capitals are gone. Well, let's do that. If it's a small letter, more than a small letter A, and it's also less than or equal to C, then I know the next digit is a 2. Oh, I can't compare a letter to, sorry, a character to a string. I've got to compare two characters to each other. firstly. And secondly, I don't want to make the whole number equal to this digit. I just want to add the digit to the end of the number. Okay, and then I'm going to do the same thing for the other letters. So if it's D, E, or F, that's on key 3. And I like to write my else if like that. I need key 3, 4, 5, 6, 7, 8, 9. Okay, so 4, 5, 6, 7, 8, 9. And here goes from G, H to I. Let's just make sure of that. G, H, I, J, K, L. So that's J, K, if it's between J and L. M, N, O. If it's between M and O. Then the next one is P, Q, R, S. P, Q, R, S. T, U, V. And now I made a mistake. T, U, oops, same mistake. And W to Z. So you can see that keys digit 0 and digit 1 are never used. And if your phone number contains those digits, then you're screwed. I mean, you should have chosen a better phone number for your company. But especially in the United States, it's very common for companies to choose numbers, and they make sure that they choose either these numbers, or if the 0 and 1 fits into their name, like Coke 0, maybe they could somehow work the 0 into that. Okay, so if it's none of those, I actually want to print out a little message. Out. System. This is what I want to do. Could not map letter. I'm hoping that this will never happen, so that all the words in my dictionary, all of these, can be mapped to a digit. But just in case I come across a letter that cannot be mapped, I will see this message. I think it'll never work. Okay, so let's just start a recap. Number starts empty. I have a for loop that goes through each letter in this word. It checks if the character is between A and C, and if so, it adds a 2 to my number string, or if it's from D to F, it adds a 3, and it does this for each of the letters in the word. And finally, I've got in number the telephone number or string of digits that correspond to that word. So this is how I translate words to numbers. Fine, I'm happy with that. Here I made a mistake on purpose, and I hope by this time everybody is screaming. I asked if translation is equal to number. This will never be true. Number is something that I got from the command line. Translation is a new string that I constructed in this method. They're both instances of string, but those instances are never equal to each other. They're two separate instances. If I want to compare strings, I cannot use double equal sign. I must use equals, this method here. Number. Okay, right. So, what am I thinking? I'm thinking that this will work. I'm reading a number from the command line. The dictionary I'm going to take out because I don't want to read that. I open this file with this in object, and I scan through it, translating each word and checking if the translation is equal to the number. So it translates from the word to a telephone number, and I check if that's equal to the target telephone number that I got from the command line. And if it is, I print that word because it's a possible match for my phone number. This will work. for any 7-digit numbers, any 4-digit numbers, and any 3-digit numbers. And that's because those are the only words that appear in my dictionary. We know what's in this dictionary. It's 3, 4, and 7-letter words. So if I put in a different number of digits, it's not going to work. And I should really be checking that number is a 7-letter, a 7-digit number. But let's forget about that for now. Okay, I'm going to run this and see what happens. This should work for 7-letter. Okay, it's complaining there's no command line argument. Run configurations. For phone words, I want command line argument to be string prompt. Apply and run again. And let's pick the number we had in the tutorial. It was this 2667883. 2667883. Oh, a lot of letters it couldn't map. Now, what do you think that letter was? I suspect that letter was the end of the line. Now, how am I going to get rid of that? Well, one part of me says, well, let's just leave out this else because it's just the end of the line. It's not really a funny letter. Well, let's just make sure. Let's print the letter. Add the letter. Let's just see what the letter is. I mean, if it's a funny character like an A with an umlaut on it, diaresis on it, we'll see what's going on. Oh, it's P and R and S. I made a big mistake. Oh, C. You see what happened. I put in the else statement because I was afraid that something might go wrong, and I was proven right. It helped me. It helped me because I suddenly saw that, oh yes, it's not recognizing P and R and S, and I noticed that those were the only letters it was complaining about. So I could instantly check this line, and I saw I did make a mistake. Right, let's try again. Wonder if it'll work. Okay, so it's not so nice here at the end. There's some problem, but it did print words. It found words. Okay, good. I'm happy with that. This, I think, happens because I think it gets to the end of the file. Does this file have an empty line at the end? It does. 26,000 words. But let's delete the empty line and see if this mistake goes away. If it doesn't, it's something else, obviously, that I have to fix. But let's just see. It works. Perfect. Okay. Those are the only two words that this number spells. Let's just pick a random number and see if there's any interesting ones. Now, I can't do 1, 2, 3, 4, 5 because with 1, 2, 3 I can go A, B, A, I mean, stuff like that. But I'm just going to pick a random number. It stopped, so I didn't find any words. Oh, well. Tells you what I know. We'll work backwards a little later. Cool, right. So those are the 7-letter words, but it's supposed to take a 7-digit phone number and also find words that are 3 and 4 that next to each other that can be next to each other. So how are we going to do that? And my plan is to scan this file twice. Now, I don't really want to do that because scanning a file more than once, in fact, I'm not going to do that. Scanning a file more than once is really time consuming. Reading from a disk is a time consuming operation. So, I want to read it only once. But that would mean that I may have to remember all the words. And in fact, that is exactly what I'm going to do. I'm going to make 6 arrays. I'm going to make 6 arrays, string arrays. One I'm going to call word 3, and that'll hold all my 3-letter words, and then I'm going to have word 4 and word 7. And those are 3 of my arrays, and also I'm going to have 3 more arrays called number 3, word number 4, and number 7. I'm going to read the dictionary. I'm going to put the words in one of these 3 arrays, and then I am going to scan through these arrays to see if I can find matches for my phone number. So as I read words 3, 4, 7.text, I'm going to put the next word either in word 3 or word 4 or word 7, and at the same time I'm going to translate it and put its translation in number 7, number 4 or number 3. How big should these arrays be? Now comes the fun part. One of the reasons I want to use only this file is because I can do a dirty trick. I can look at the file and count how many where's my workspace? I can count how many 3-letter, 4-letter and 7-letter words there are. So there is my dictionary. I'm going to count how many words have 3 letters in this file. How do I do that? I guess I put a -c in here. Okay, so there are 1,135 3-letter words. So let's make this array that size. And I know there are cats behind me, don't worry. I'm also going to make that array that size. Okay, next. How many 4-letter words? 4,347. So that's how big my 4-letter array will be. Okay, and how many 7-letter words? 20,000. Okay. Right. And some of these words are obscure. I can't imagine a business being called Abacate. Okay, but that's fine. Maybe. Nice. Okay, right. So there are my 3 arrays. Now let's come here. I've read a word from the dictionary file. I'm going to say if word.length is 3, then put it in the 3 array. Word 3 something is equal to this word, and number 3 something is equal to the translation of this word. Okay, how do I know where to put it? Well, the first 3-letter word should be at index 0 in word 3, then index 1, then index 2. So I have to keep track of how many of these 3-letter, 4-letter, 7-letter words I've seen. So I will also need a counter. Count 3, count 4, count 7. And they all start at 0. Okay. So let's put the first 3-letter word in count 3. You see, this is not such a simple problem. We thought, oh, easy, because it's so short. But actually to do it right is quite difficult. If the word length is 3, then do that. But now, I think, if we're careful, it should be a little easier. If the word length is 4, put it in the 4 array. Translate word 4 array. And else, we just put it in the 7 array. I don't even have to check, because I know there are only 3, 4, and 7 letter words. So that should be 7, 7, 7, 7, 7. Rightio. There we go. So I've read all the words and I've put each word in the correct array, and I've also put its translation in the number arrays. And now I can just use a for loop. For I is equal to 0, I less than count 7, I plus plus. If the number 7 of the ith word, if that is equals to my, come on Eclipse, I should do something about that. If that is equal to the number, my target number, target phone number, I should just print out the corresponding word. Okay, and then I'll have 2 more for loops for the 3 and 4 letter words. Now this is tricky. Let's go through all the 3 letter words. If my number starts with the ith 3 letter word, if my phone number starts with the translation of the ith 3 letter word, then I've got a chance of making a little phrase. So a 3 letter word followed by a 4 letter word. So I know what the 3 letter word is. I've just found that the ith 3 letter word actually matches my phone number. Now I've got to find a 4 letter word that matches the end. So I'm going to have another for loop that goes through all the 4 letter words, and it's going to do this over and over, but I can live with that. If number ends with number 4J, then I'm going to print a combination of the 3 and 4 letter word. Word 3I plus a hyphen plus word 4J. There we go. And this, believe it or not, is my whole program. I'm going to write nothing more. Okay, so what are the tricky parts? Let's just review. I had the first approach, which only worked for 7 letter words. But then I had a plan. I decided to store the dictionary in these arrays. That meant I had to count the number of words, 3 and 4 and 7 letter words. I had to read the dictionary and put it in the arrays. And then I had to write these for loops. One for all the 7 letter words, which is quite similar to my old code. And then a for loop to pick up the prefixes, and a nested for loop to pick up the suffixes. And the other tricky part was just the translate method. But I think this will work. I have to do a little bit of mental work, but I think that's okay. Let's go back to 266. What was the number? 7883. 7883. Let's see. We know those 2 7-letter words that will match it, but here we get a lot of nonsense phrases that can also match. And stud, and stew, bomb stud, bomb stew. I mean, none of this makes sense. I mean, maybe this is the name of your business, but it doesn't mean so much to me. Let's work in reverse and see if we can check it like that. So I'm going to think of a word that I want it to be. Can swim. Okay, let's see. What would the number be for can swim? That's a 2, 2. N is on 6. 2, 2, 6. And swim is on, I used to know this off the top of my head. 7. W is 9. I is 4. and M is 6. Okay, so this number one option should be can swim. It may be other things as well, but let's see if it's can swim in there. Oh, this is another long video. Will there never be a short tutorial video? Right. What are the options for this phrase? Okay, let's have a look. No 7-letter words, but here we at the bottom we see that can swim is one of the options. So if I was a company, let's say I'm a swimming instructor, I would choose this number because it can spell out can swim. I can tell clients just type can swim on your phone and you'll get me, you'll reach me. Okay, fine. I'm gonna stop because way over time. Gotta go faster in the future, but this is good enough for now. Thanks, guys.